Hello, today we will be talking about mathematical operations. So, mathematical operations are actions performed on numbers or expressions to produce a new value. We have some basic arithmetic operations such as addition, subtraction, multiplication, and division. And we also have other operations such as absolute value, exponentiation, roots, logarithms, etc. In this presentation, we will focus on the basic operations and also on absolute value, exponentiation, and roots. Let's start with absolute value. For that, we need to remember the use of the number line. So the number line contains positive integers such as 1, 2, 3, 4, and so forth. It also contains the zero number and the negative integers, right? Negative 1, negative 2, negative 3, and so forth. Now, the absolute value of a number is defined as its magnitude or distance from 0 to the number. Remember that the distance is always a positive number. For example, if we want to find the absolute value of positive 4, we take our number line and we just calculate the distance from 0 to positive 4. And that distance is going to be 4. So that's what the absolute value of positive 4 is, 4. Positive 4. Now the absolute value of negative 4 would be the distance between 0 and negative 4, and that distance is 4. So it will be positive 4. So in other words, it doesn't matter what number we put inside the absolute value. If we put a positive number, the result is the same positive number. If we put a negative number, the result is a positive number. So the result always will be a positive number, the positive version of whatever is inside the absolute value. Okay, now we're going to be talking about addition of two integers which have the same sign. When we have two integers that have the same sign, 3 plus 2, remember this is the same as saying positive 3 plus positive 2. We take the number line and we start at positive 3, and because we have to add 2, a positive 2, we're going to move to the right. Okay, so we're going to move 1 unit to the right and 2 units to the right, so we arrive in positive 5. So that's why positive 3 plus positive 2 is positive 5. Now if we have negative 3 minus 2, same thing, we go to the number line, we start in negative 3, but because of this negative 2, we're going to move, or this minus 2, we're going to move 2 units to the left. So remember, when we subtract something, we move to the left. When we add something, we move to the right. So in this case, we move 2 units to the left, 1, 2. So we land in negative 5. So negative 3 minus 2 equals negative 5. Now, as a general rule, when you have same signs, you always add the values, the absolute values of the numbers. And you use the same sign of both numbers in the result. Right? If we have positive 3 plus positive 2, you take the absolute values of them, basically you get the same numbers, right? You get positive 3 plus positive 2. And the result is 5. You add them, and because both numbers are positive, so the result is going to be positive. Now you have negative 3 minus 2. You get the absolute value of both of them. Absolute value of negative 3 is positive 3. Absolute value of negative 2 is positive 2. And you add them just like before. You get 5. You put a number, and because both of these guys have negative signs, the result is going to be negative. So same signs, you add them and you put the same sign that both numbers have. Now, when you add two integers with different signs, for example, here you have 3 minus 2. Just remember, that's the same as positive 3 minus 2. Here, both of them have different signs. So you take the number line, you start in the positive 3, and because it's minus 2, you're going to move 2 to the left. 1, 2, and you land in 1. So the result will be positive 1. Now you got negative 3 plus 2. Same thing, you take your number line, you start in negative 3, and now plus 2 means you want to move 2 to the right. 1, 2. So you land in negative 1. So that's the result. So as a general rule, when you have different signs, you're going to subtract the absolute values of the numbers and use the sign of the larger absolute value number in the result. For example, here, right, you have positive 3 minus 2, you get the absolute values of each one. Absolute value of positive 3 is positive 3, absolute value of negative 2 is positive 2, and you subtract them. Again, if you start with different signs, positive and negative, you're going to subtract their values, their absolute values, right? 3 minus 2 is 1. So you take that 1, and you're going to put the sign of the bigger absolute value number. Which of these numbers, just look at the numbers and don't look at the sign, are bigger, 3 or 2? 3 is bigger. So that's the sign you're going to use, the positive sign, because that's the one of the bigger number. Positive 3 has the positive sign. 3 is the bigger number, so that's the sign you use. Now you have negative 3 plus 2. Same thing, you take the absolute values of each one, which would be absolute value of negative 3 is positive 3, absolute value of positive 2 is positive 2, and you subtract them. Again, I repeat, whenever you start with different signs, you're going to subtract their values, okay? Their absolute values. 3 minus 2 is 1. Now you take that 1 and you ask the same question. Which of these two numbers is bigger? Don't look at the sign, just look at the numbers. 3 or 2? 3 is bigger, so you're going to use a negative in the answer. So the answer is negative 1. Okay? So different signs, you subtract the numbers, and the sign that you use is going to be of the number that looks bigger, regardless of the sign. Now, when you add more than two integers, you just follow these rules. It's just step by step. Here, you start with 3 and 2. 3 plus 2, 5, and then 5 plus 4, 9. Here, same thing. You take these two numbers, negative 3 and negative 2 will be negative 5. And then negative 5 minus 4 will be negative 9. You do 2 at a time. Here, negative 3 plus 2 would be negative 1. And negative 1 minus 4 would be negative 5. Now, let's go into multiplication and division of two numbers. Let's start with multiplication. 3 times 2. When you multiply 3 times 2, what you really mean is that you want to add 3 2 times. Okay? So you take the first number and you say, okay, I'm going to add this number 2 times by itself, right? And 3 plus 3, 2 times. That's what multiplication means. And of course, the result is 6. 5 times 3, you're going to add the 5 3 times by itself, right? 5 plus 5 plus 5. Okay? And the result is 15. 5 plus 5, 10. 10 plus 5, 15. Of course, you're encouraged to revise or to review the multiplication tables, right? Where you memorize basically all these multiplications. Now, let's go into division, right? To define division. When we say, for example, 6 divided by 2, let's say we have 6 apples, and we want to divide these apples in 2 groups. So each group is going to have 3 apples, right? 3 apples in each group. We're dividing in 2 groups. Each group has 3 apples. So that's why 6 divided by 2 is 3. Division is also known as the opposite of multiplication. But first I want to go over the definition, the simple definition, so things are clear from the beginning. Now, if we divide 6 divided by 3, same thing, we have 6 apples, but now we are going to divide them in 3 groups because it's divided by 3. So each group is going to have 2 apples. So 6 divided by 3 equals 2. Now let's go into the multiplication and division of 2 numbers, the sign rules. Okay? So when the signs are the same, the result is always positive. Again, this is when you multiply and divide. It's different the rules when you add or subtract. Now we are multiplying and dividing. So same signs, positive result. For example, right? For example, positive 6 times positive 3 is positive 18. You see, both of them have the same sign, which is positive, positive. So the result is positive. 18, positive 18 divided by positive 3 is positive 6. Positive divided by positive is positive. Same signs always give you positive. Now let's go into the case where it's the same sign, but both are negative. Same thing, the result is positive. When both signs are the same, doesn't matter if you're multiplying or dividing, as long as both of them are the same sign, the result always will be positive, as this rule says. As this example, we put negative 6 times negative 3, both are negatives, so 6 times 3 is 18, and the result is positive because the signs are the same. Same signs give you positive. When you divide, same thing. Negative 18 divided by negative 3 is positive 6. Both of them have the same sign, both negative, and the result is positive. So again, as long as these guys have the same sign, both positive or both negative, the result will always be positive. Now, if the signs are different, then the result is negative, right? For example, here, a positive times a negative, or a positive divided by a negative, is going to be negative. Different signs, result is negative. For example, positive 6 times negative 3 is negative 18. Positive 18 divided by negative 3, positive divided by a negative, different signs, the result is negative 6. Here is the same, the signs are different. Negative times positive, or negative divided by a positive, the result is negative. Negative 6 times positive 3, negative 18. Different signs, result is negative when you multiply or divide. Negative 18 divided by positive 3 is negative 6. Different signs, negative divided by positive, the result is negative. So just remember, if the signs are the same, when you multiply or divide, you get a positive result. If the signs are different, when you multiply or divide, the result is negative. That's the rule. Now let's go into exponentiation. An expression used to represent the product of a repeated multiplication is called a power. For example, 2 times 2 times 2 times 2 times 2 times 2 times 2. Remember, when we put numbers in parentheses together, we're multiplying them. Here we're multiplying that 2 7 times. So we express that like this, 2 to the power of 7, where 2 is the base, the number that repeats, and 7 indicates how many times it repeats in the multiplication. That's called the exponent. Now in this case the result is 128. The power 2 to the 7 or 2 to the power of 7 can be read as 2 to the power of 7 or 2 to the 7th power or the 7th power of 2 or 2 raised to the 7th power. So there is different ways to refer to this expression here. I usually use 2 to the power of 7, or even I say 2 to the 7 sometimes to be short. Now, the power 5 to the 2 to the power of 2 can be read as 5 squared. So every time you have a 2 in the exponent, you can use this word square, 5 squared. Or you can call it 5 to the power of 2, or 5 to the second power, or the second power of 5. Usually you call it 5 squared. Every time you have 2 as an exponent, you use the word square. 5 to the power of 2 will be 5 times 5, which is 25. Now the power 5 to the 3 can be read as 5 cubed. Whenever you have an exponent 3, you use this word cube, 5 cubed. You can also refer to that as 5 to the power of 3 or the third power of 5. But again, we usually use the expression cube when the exponent is 3 and square when the exponent is 2. And in this case, 5 to the power of 3 would be 5 times 5 times 5, which is 125. Now let's go into roots. Roots, also known as radicals, are the inverse of powers. Okay? Let's take a look at this example. This number here is going to be called the index. This number here, the 8th in this case, is going to be called the radicand. And that symbol is called the radical symbol. So we have 3 elements, right? We have the index, the radical symbol, and the radicand inside the radical symbol. So what's the value, what's the answer of this? Basically, we're looking for a number that multiply the index number of times, in this case 3 times, give you 8. So one number multiplied by itself 3 times, right, give you 8. The answer will be 2. 2 times 2 times 2 give you 8. So the answer of cube root of 8 is 2. Okay? When the index is 2, like in this example, right, we don't write the index. So when you don't see a number in the index, you should know that that number is 2. It's just that we are not writing it. And this is read as a square root of 9, which would be 3, because 3 times 3 is 9. You're looking for a number that multiply the index number of times, in this case 2 times, give you the radicand, which is 9. And the number will be 3, because 3 times 3 equals 9. Now, when the index is 3, for example here, you read this as cube root of 8. Okay, again, if the index is 2 is a square root, and the index is 3 is cube root of 8. And cube root of 8 is 2 because one number multiplied 3 times by itself give you 8 is 2. 2 times 2 times 2 give you 8. Okay. Now, when the index is 4, like in this example, we call it fourth root of 16. So we have special names when the index is 2 and when the index is 3. But when the index is fourth, we call it fourth root. If the index is 5, we call it fifth root. 6, sixth root, and so forth. Okay? So fourth root of 16 would be 2, because a number that multiplies 4 times by itself gives you 16 is 2. Remember, the index tells you how many times you need to multiply that number by itself, and the radicand is the result you're supposed to get. Now, something to be careful about exponents is that how you express them or how you solve them. In this example, if they give you something like negative 5 to the power of 2, that negative is affecting the result. Okay? So that would be negative 5 times 5, which is negative 25. That's different if you have a parenthesis here. So it would be negative 5 to the power of 2 would be negative 5 times negative 5, which is positive 25. So be careful, okay? If they put a parenthesis, is different than if they don't. In one case, the result is negative, and in the other case, the result is positive. Now, to finalize this, remember, there are numbers called perfect squares, which are the result of multiplying a number by itself. Like 2 times 2 is 2 to the power of 2 or 4. 3 times 3, 3 to the power of 2 or 9. 4 times 4, 4 to the power of 2 or 16, and so forth. All these numbers, 4, 9, 16, 25, 36, 49, and so forth, are called perfect squares, because they are the result of multiplying a number by itself, or basically raising a number to the power of 2. You see, all of them are the result of taking a number, a natural number, and raising that to the power of 2. That's why they are called perfect squares. And why are these numbers important? Is because all of them will give you a natural number, an integer, right? And a positive integer when you square root them. Square root of 4 is 2, because 2 times 2 is 4. Square root of 9 is 3, because 3 times 3 is 9, and so forth. So all these perfect squares are important because the square root of them is a positive integer. And later you will see how this is important to simplify radicals, as we will see later on. Thank you very much. That's all for this presentation.